Hello and welcome to lesson 6D. I can simplify exponential expressions. So if you recall, exponents signify repeated multiplication. So y to the sixth in reality is equal to y times y times y times y times y times y. So whenever we say to write an exponent in expanded form, that's to write it out all of those times. So 2 to the fifth is really 2 times 2 times 2 times 2 times 2. 3x to the fourth, when I don't have a parenthesis around the 3x, is really 3 times x times x times x times x. And I apologize for the little mark there. And negative m squared, again, think about your parentheses, is really negative m times m. So let's take a look at this next example. If I want to expand and then simplify. X squared times x to the fourth. Well, x squared is really x times x, and x to the fourth is x times x times x times x. Well, when I look at this, I've got 2 and then another 4, I've got 6 x's. So this is the same as x to the sixth. So that leads me to my product rule. When I have two things of the same base with exponents multiplying each other, what I'm going to do is I'm going to add their bases. So x to the m times x to the n is x to the m plus n. So when applying exponent rules, you should keep the base the same. Base do not change. Now let's take a look at this next section. I want to now simplify each expression. Well, 2 squared times 2 to the fifth is really 2 to the 2 plus 5, or 2 to the seventh. Part B, y times y cubed times y to the fourth is really y, that's to the 1, we don't have to write it, but it's there, to the 1 plus 3 plus 4, which is y to the eighth. These can get a little bit more complicated. Now I've got different bases. I have some constants. We take each thing in turn. The first thing I want to do is I want to multiply my constants. 3 times 5 is 15. Then I want to look at the a's. I've got a squared and then an a to the 1 that I don't always see, so that's a to the 2 plus 1. And then I have a c to the 10 plus c to another 10. So my final answer is 15a cubed c to the 20th. Let's keep looking. We can keep doing this even when we have variables as our exponents. This guy would just be n to the x plus 2. So we simply add our exponents. And here, this would be m. I do 2x minus 1 plus 5x plus 2. So that ends up being m, 2x plus 5x is 7x, and plus 1. Not too bad. I want you guys now to do these next 4 as a try me. Go ahead and work through it, and we'll check our answers here in a second. Go ahead and check your answers. Let's look at the next section. If a does not equal 0, then a to the 0 equals 1. And there's actually a really cool reason for this, which we'll explain later, actually. But let's go through and evaluate these. When I look at this 5 to the 0, that's just 1. Negative 5 to the 0 is the same thing as negative 5 to the 0 is 1, so it's just negative 1. 3x minus 7 all to the 0 is 1. 2x to the 0 would be 2 times 1, which is just 2. So notice the difference. Here, the 0 exponent applies to this whole thing, whereas here the 0 exponent only applies to the x, not the 2. Right? So that's the distinction there. Let's take a look at this. Expand and simplify. A to the sixth is a times a times a times a times a times a over a squared is a times a. When I do that, some of these cancel. And I'm left with a to the fourth. Well, if you notice, that's the same thing as a to the 6 minus 2. So my quotient rule says if a is a non-zero real number and n and m are integers, then if I divide a to the m by a to the n, then my solution is a to the m minus n. So notice that there is a common base, and it cannot be 0. All right, let's take a look at these. So 7 to the 8 over 7 cubed is going to be 7 to the 8 minus 3, or 7 to the 5th. On this guy, we first deal with our constants. 30 divided by 6 is 5, and then I have x to the 4 minus 3, so I get 5x to the 1, which I don't need to write. Here we can simplify the constants. 16 and 18 are both divisible by 2. I'd get 8 over 9. So here we have 8 over 9. And then we look at our m's. I get m to the 12 minus 5 and n to the 5 minus 5. Well, 8 over 9 stays. I get m to the 7th, n to the 0. But we already discovered that anything to the 0 is 1. So that's just equal to 8 over 9, m to the 7th, and we're done. The n went away. So then d here, when I look at d, it's just going to be a nice subtraction problem. X to the 2k minus 5, and it cannot simplify anymore. All right, guys, I want y'all now to go through and do these 4 try-me's. Go ahead and check your answers, and we'll discuss them in class. All right, let's take a look at this guy, expand and simplify. So here I get x times x times x over x to the 5th, which is x times x times x times x times x. When I simplify, 3 of those cancel, leaving nothing in the numerator, so we replace it with a 1, and 2 x's in the bottom. That becomes x squared. So that becomes 1 over x squared. Well, if I were to use the quotient rule here, this would be x to the 3 minus 5, which is, whoa, sorry guys, which is x to the negative 2. Well, that must mean that x to the negative 2 must be the same thing as 1 over x squared, which actually leads me to my negative exponent law. If a is a real number other than 0 and n is a positive integer, then a to the negative n is 1 over a to the n. And we always want to write our negative exponents instead as fractions. So let's take a look at these guys. No, stop moving. Sorry, guys. Having a day with the pen. All right, so 4 to the negative 3rd is the same thing as 1 over 4 to the 3rd, which is really 1 over 64 if we're going to go full. Okay. Negative 3 to the negative 4 is the same thing as 1. Oh my gosh. Sorry, folks. Do you ever just have those days, guys, where none of your technology is behaving the way you want it to and you keep hitting the wrong button with your elbow? I'm having that day. Okay, let's try this again. 1 over negative 3 to the 4th, which is, in fact, 1 over 81. Well, 5y to the negative 3rd. Well, if you look, the 5 is not attached to the negative 3, so the 5 can stay in my numerator. But the y to the negative 3rd is going to go to the denominator and become y cubed. So you notice they separate. Whereas in part D, the negative 1 is applying to the whole fraction. So this guy is really 1 over 4x. And by whole fraction, I meant whole part of the expression. So k to the 4th over k to the 8th is again 1 over k to the 4th, and 2 squared over 2 to the 7th. If we were doing this with our exponent laws, that would be 2 to the negative 5, which is equal to 1 over 2 to the 5th. So, and then we keep going. Here I have 3 to the negative 2 plus 4 to the negative 1. Well, 3 to the negative 2 would be 1 over 3 squared. And then 4 to the negative 1 would be 1 over 4, or 1/9 plus 1/4. Folks, we can keep simplifying. Common denominator here would be 36. Yes, so we're going to make this 4 over 36 plus 9 over 36, which is equal to 13 over 36 for my final answer there. And then this is a tricky one, 1 over x to the negative 4. When we have our negative exponents in the denominator, it's actually going to flip up to the numerator. So this guy just becomes positive x to the positive 4 in the numerator, and the over 1 would go away. Let's look at our helpful hint. When a vector containing an exponent is moved from the numerator to the denominator, or from the denominator to the numerator, the sign of the exponent changes. So here, if we start with an x to the negative 3, it becomes 1 over x cubed. 5 to the negative 2 becomes 1 over 5 squared. 1 over y to the negative 4 becomes y to the positive 4. 1 over 2 to the negative 3 becomes 2 to the 3rd. So now, guys, I want you all to stop and try these 3 questions. All right, guys, go ahead and check your answers. I just made a mistake. Go ahead and check your answers. Let's take a look at the last piece. Okay, now we're going to make these a little bit more complicated and simplify and write with positive exponents only. So my recommendation here is to use your laws to your best advantage. So here, this would become y to the negative 11 minus 2 with my quotient rule, which is y to the negative 13th. Well, that's the same thing as 1 over y to the 13th. Similarly here, the 6 just hangs out. He doesn't have a buddy. And this becomes u to the 5 minus negative 3, which is equal to 6u to the 8th. This guy, this would be 3 to the negative 4 minus negative 2, which is the same thing as 3 to the negative 2, or 1 over 3 squared, which we could call 1/9 if we wanted to. Here we're now going to take each exponent in its own turn. I first start off by simplifying the constants. 3 and 12 become 1/4. X to the negative 4 minus 1. And then we have y to the 5 minus negative 3. So this becomes 1 over x to the negative 5, or actually, let's keep that. 1/4 x to the negative 5 y to the 8th. And now the negative exponent, of course, has to flip to my denominator. So that becomes y to the 8th over 4x to the 5th. I didn't have to write the 1 because we never have to write times 1 in front of anything. This guy, I'm going to first use my quotient rule first. So I get 5x to the negative 9 plus 4 over x cubed, which is 5x to the negative 5 over x cubed. Then I'm going to use, so I use the product rule, now I'm going to use the quotient rule. 5x to the negative 5 minus 3, which is 5x to the negative 8th, and finally I'm going to flip my fraction. 5 over, holy moly, sorry guys, 5 over x to the 8th. All right, friends, y'all try these. Take a look and check your answers. All right, guys, thank you so much. Take a look at the practice, and we'll see you in class to talk all this out.